Hey everybody, this is Larry. This is day 27 of the Leetcode Daily Challenge. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about today's problem. It seems like we're done with 3-ish graph problems, maybe. Let's see, 64, minimum path sum. So given an m by n grid, non-negative numbers, find a path from top left to bottom right. And this is, of course, going to be very standard-ish dynamic programming. I mean, I don't think any dynamic programming problem should be labeled as easy, but to be frank, this is probably as easy as it gets for dynamic programming. I think this is probably one of the first couple of different variety of dynamic program problems that you'll run into, and definitely I consider it very fair game for interviews in general. There was a time when I think dynamic programming was a little bit too hard, but I think these days things are just getting harder and harder, right? So it is what it is. But yeah, and this is I don't know, this is pretty well known, I suppose. So yeah. So basically, the way that I would think about it, if you haven't already done this one, I think there are probably good videos on this exact problem because it is a way thing. But I think I want to just point out a couple of observations in either case. The first thing is that dynamic programming works on this particular problem because the grid function is a graph, right? And not just any graph, but a directed asynchronous graph, which means a DAG in other words. And because there are no cycles, then you can kind of almost have this recursive structure of, okay, what's the best what was the best result we can get from this cell, which is a function of other cells in itself and so forth, right? So that's basically the way that to think about it. And it's gonna be 200 by 200, so that should be good. But yeah, always good length of grid. Oops. Can type. Wow, I'm really. All right, let me reset my hands because apparently maybe I don't know. Right. And then basically you can, in this particular problem, it is symmetric, meaning that you can go in either direction from the beginning to the end or the end to the beginning. It's not always the case in general, so definitely something to look out for. If you're finding it to be a little bit wrong, then you have to kind of interpret it, or you have to make sure why, or you have to check to make sure why your function is not symmetric, and you have to figure out how to get around it, right? Addition in this particular case, or sum, is going to be symmetric because it's commutative and so forth. Yeah, commutative. But there are versions, right? Like you have min functions and max functions and stuff like this. Then it may not be depending on how the rules of the thing is. So definitely be careful about it. But yeah, but I'm just going to do a really basic x, y, right? And then basically if x is equal to r minus 1 and y is equal to c minus 1, then we return the thing at that, or maybe return 0. I don't know how we want to. I mean, that is just a base case, right? So then now you go go right rather. Go right is equal to calculate of x, y plus 1, and just assume, of course, y plus 1 is less than c, right? If x plus 1 is less than r, then down is equal to calculate x plus 1 y, and then you just return min of right and down, kind of plus grid of xy, right? Because that's just the cost of the rate of the current grid cell, and then to comment down. This is not going to necessarily compile, but that's fine, right? And then you just return calculate from 0, 0, and it should be mostly good except for the memorization part. Did I mess something up? Did I mess something up? Why is this not read? I mean, there is, like I said, we didn't do the memorization part, but so this wasn't going to be right, but That's weird. I usually write this differently, but so maybe that's why, but still. One, so from 0, 0, 1, 2, 2, 2, what's 2, 2? 2, 2 just return, so then 2, 1 is 2. Man, this is embarrassing. I'm clearly missing something very silly. But I don't know what is going on. Okay, so with this particular one, 0, 0 is going to be 5. Why? Oh, I'm dumb. This has to be... Okay. I'm very silly. I think, and we do recall, I initially thought it was max sum for some reason, and this particular problem, it goes like minimizing and maximizing doesn't, or like it used the same end or same idea. So I kind of, wow, what a silly mistake. So you need, to keep min, it was just doing 0 the entire time. So yeah, okay. So yeah, so we cannot submit because, like, if you do a bigger case, this is going to time out, because as you can even see it from the print statement previously, you're reusing states, right? But as you can also see from this print statement, every time you have the same input, which is the first 2 cells, the first 2 parameters, you're gonna always get the same thing. So we're gonna do this thing called memorization. And the way that I always write memorization is just by doing something like this. Has cache is you go to force. Sorry if I'm a little off today. I'm kind of I'm doing a fast. I am, what time is it? I'm about 26 hours into the fast. I actually feel great, but I don't know. I think I have a little bit of a clarity with respect to, like, I actually feel great for the most part. I walked 10 miles today, which is because I don't know. If you can't eat, what else can you do? 11 miles? But I don't know. Something feels a little bit off, but not necessarily in a bad way, but I just have to kind of adjust to it. I'm going to do this fast for another... I wanted to, my initial goal is 72 days, but I have a couple of workouts, tough workouts coming up. So we'll see how I feel after that, and if I have compliance about it. And yeah, anyway, but yeah, usually I do my updates in the beginning, so sorry for the bait and switch. But yeah, but if the cache exists, then we set update the cache, or we return the cache. Otherwise, we just update the cache. And then we set the cache, you go to this answer that we return. And then that's pretty much it, really. Yeah, it looks fast, maybe. Let's give it some submit. Hopefully I don't have a weird typo. And luckily I do not. The streak is 1091. Yeah, what is the complexity here, right? For dynamic programming, I mean, and there are optimizations you can do to this one, for example, the space optimization, but we'll just ignore that for now. The space is going to be, you can just look at this and count, which is O of R times C, which is linear in the size of the input. For the time, well, X and Y, it's going to have O of R times C number of distinct input, and each input takes O of 1 time, because we just kind of, yeah, we just do a couple of lookups. So total time is O of R times C time. And that's pretty much it. And also O of R times C space. As I said, you can actually, there's a space optimization. I'm not going to go over it now, but you can watch my video. I forget which form I used for that one, but it's very similar. So I think you can figure that out for dynamic programming progression. So yeah, that's all I have for this one. Let me know what you think. Hope y'all have a great week. And yeah. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.